Hello and welcome. So what we're going to do today is we're going to write similarity statements for triangles. So we're already going to assume that we have similar triangles, that our triangles are similar to each other. In which case, all we need to do is write the similarity statement. We can't just, pick random sides and be like, oh yeah, AKD, triangle AKD is similar to, and then just pick some more random sides where like maybe you want to go like BQD or something like that. Okay, I don't know. Maybe the triangle, I just guess, actually does work. I'm not sure. Okay, you got to be careful that when you're guessing, not guessing, but when you're writing your similarity statement, you actually have to stay consistent. So, what I mean by consistent. So, you'll notice that for this triangle here, we picked AKD. So, that means that A goes to K goes to D. So, what we're doing is we're saying, okay, A goes to K, and then from there, we're going to say K goes to D. Now you'll notice that we're given three sides here. So how can we determine what the equivalent similarity statement for the other triangle is? Well, let's look at our AKD here. Well, from A to K to D, you'll notice that we have three measurements. We have 7, we have 6, we have 4. 7 is the largest side. 6 is like the medium side. 4 is the smallest. So we go from the vertice that's between the smallest and largest, which for our three numbers here is going to be D. Because you'll notice of these three numbers, 28 is the smallest, 49 is the largest, and then 42 is the medium. Which means that if we want to write an equivalent similarity statement, you got to start at D. So triangle AKD is similar to triangle D2, and then from there, run it over. So we started at A, we went to K, where it was traveling along the largest side. So largest side would then go to Q, where Q is that vertice between the largest and like the medium side. So D, Q, and then we go to the smallest, the other vertice. There's only one left, which is going to be B, which travels along that medium side, which we'll notice it does the exact same thing on our original triangle. And this is an equivalent similarity statement. Okay, so let's try it again, but maybe not with sides. What if we were given something like this? Well, we don't have any sides, but we are given something that is very important here. And that's going to be your right angle. Okay, for this particular triangle, if you're not given any side measurements, these would have to be the figure would have to be correct for what we see, which it will be. Alright, if you're ever asked to write something like this. Here, the figure may not be correct proportionally, right? But we are given the side length, so it doesn't matter whether the figure is correct or not. Alright, when it comes to these ones, the figure would have to be correct, which, again, it is. So then you'd say, alright, well, we'd have to be given the original similarity statement, so let's just pick one. I don't know, PRH. So triangle PRH. How did I pick that? Randomly, right? We could have done HPR, or maybe we could have done struggle, guys. RHP, right? It doesn't matter how we want to say that first one. Once it's decided, though, then you have to go with the same pattern for the next triangle. So, right. So we started at P, which is between the hypotenuse and the longest leg. So here's your hypotenuse, here's your longest leg. So if P was the top vertice, then that means I is the equivalent vertice in the other triangle. Okay, then we went to R, which was next to your right angle, right, down there, which its equivalent would be K in the other triangle. And then last but not least, it would have to end at L, which is traveling along the shortest side. So R goes to H as K goes to L. And that would be your last similar triangle statement, right? And it doesn't matter what you're given. If you're given all angles, like maybe we didn't know that these particular triangles were like the figure wasn't exact for this one, then we'd have to maybe know an angle. Let's say that we know that this one is 30 degrees. Nope, I'm going to call that one 60 degrees. Ha ha ha. And we're going to call maybe this one 30 degrees. Well, at that point, you can use your triangle sum theorem. You can say, all right, well, if we do this one, that's interior angle has to be 180. So minus the right angle, 90 minus 60, we get 30. Bam. Right? Likewise, be 180 for this triangle minus the right angle minus 30, which is 60. And you'll notice that, as we were probably told, similar triangles, in which case, bam, you now know an easier way to get to your angles, right? If we wanted to start at P, the 30, then we'd want to start at I, the 30. And then if we went to R, the 90, we would go to K, the 90. And then we would end at H, the 60. And then L, the 60. Okay? Alrighty, and that's about as crazy as it gets, honestly. For similarity statements, just be mindful that whatever this is, you gotta match that same pattern, the same proportionality, right, in order to get to the next triangle when you're writing that next similarity statement. Alright, thanks for watching.